we saw what is a concave as well as convex lens. We'll see the ray diagrams as well as the image formation by using this concave and convex lens. So, the ray diagrams and the image formation in lens are similar to what we saw in a mirror, in concave and convex mirror. The only difference is in a mirror, in a concave or a convex mirror, the light used to get reflected after falling on the mirror, whereas in the lens the light rays passes through the lens. It means that it gets refracted. So if you want to see the first ray diagram, that in the mirror there were 4 basic ray diagrams, whereas in a lens there are only 3. So what are those? So the first one, the light ray parallel to the principal axis, after refraction from a, let's take convex lens. The light ray parallel to the principal axis, after refraction from a convex lens, it passes through the principal focus. So this is a convex lens. The light ray parallel to the principal axis. This is the principal axis. So this is principal focus. This is center of curvature. Similarly, here we have principal focus, center of curvature. So we can label this as F1, C1, F2, C2. The light ray parallel to principal axis after refraction passes through principal focus. So this is the first ray diagram. So similarly, this is optic center, F1, C1, F2, C2, or you can write it as 2F2, 2F1. The light ray passing through principal focus. So after refraction, it emerges parallel to principal axis. So these two are the reverse. They are opposite to one another. So here the light ray is parallel to principal axis. After refraction, it is passing through principal focus. Whereas here the light ray is passing through principal focus. After refraction, it becomes parallel to principal axis. So next, the light ray passing through optic center, it goes in the same line or in the same path. F1, C1 is optic center O. This is F2, C2. The light ray passing through the optic center goes in the same straight line, or it goes undeviated. But actually, if we take in the real situation, there will be a slight refraction that happens here. But why do we take it parallel? So this is something related to the refraction that is taking place in a rectangular glass slab. So we'll see that maybe in the later classes. So for now, just remember that the light ray passing through the optic center goes straight without getting any deviation. But actually, in reality, there is some deviation, but we'll take it in the same straight line. Okay, so these are the basic 3 ray diagrams in a convex lens. So now, when we take a concave lens, in a concave lens, the light rays diverge. So what happens? So this is a concave lens, principal axis, optic center, F1, C1, F2, C2. Light ray parallel to principal axis. After refraction, in a concave lens, the light ray diverge. So what happens here? The light ray diverge. So when I extend this diverged light ray behind, it passes through the principal focus. So similar to what happened in a convex lens. What happened in a convex lens? Actually the refracted light ray was passing through the principal focus. But here, when I extend the refracted ray, it is passing through the principal focus, not the actual refracted ray. Next. The light ray, when a light ray falls on the convex lens in such a way that this light ray passes through the principal focus. When I extend this, if this passes through the principal focus, there is an incident light ray. So when I extend this incident light ray, if it passes through the principal focus, then the refracted ray will be parallel to the principal axis. So this is C2, C1. So I repeat, the light ray, if I extend this, if it passes through the principal focus, then the refracted light ray is parallel to principal axis. Next. Optic center. Light ray passing through the optic center goes undeviated. So F1, F2, C2, C1. So it goes in the same straight line. So using this, we'll see the image formation in convex lens as well as in a concave lens. So this is really simple. The image formations in a lens is very simple. So you just need to remember those three ray diagrams. I'll just write it small. First, let me take convex lens. Light ray parallel to principal axis passes through principal focus. F2. Next, light ray passing through principal focus, it becomes parallel to principal axis. Next, light ray passing through optic center, it goes in the same straight line. So using these three, let's see the image formation in a convex lens. So the first, when the object is at infinity. When the object is at infinity, so this is the object. When the object is at infinity, and I need to take the dotted line because this represents infinity. So let's take the parallel rays. As we took in the mirror, in the lens also, we need to take the parallel rays when the object is at infinity. So from the head, there is one light ray that is coming. So this is parallel to principal axis. So what happens? After refraction, it passes through principal focus F2. This is F1, C1. Similarly, C2, O. It passes through principal focus. So similarly, I need to take another ray from the toe. So that is parallel to principal axis. So after refraction, it passes through principal focus. So both the light rays are meeting at principal focus. So the image is getting formed at principal focus. So as in the case of mirror, we need at least minimum of 2 reflected ray in a mirror. But here, for the image formation in a lens, we need at least 2 refracted light rays to form an image. So when the object is at infinity, the image is getting formed at principal focus. So it is a real image because the light rays are meeting at a point and the image is getting formed. So what is the size? Same as in a concave mirror, when the object is at infinity, the size of the image was highly diminished or point sized. So here also it is highly diminished or point sized, and the nature is real and inverted. So one thing you need to keep this in mind is whatever the image nature and the size was there for a concave mirror, it is same in a convex lens. For the same position of the object, the image, the range or in between principal focus and center of curvature, whatever the nature was there, that is same in concave mirror as well as in a convex lens. Only the thing is here their reflection, in mirror it was reflection and in lens it is refraction. So next, optic center F1, C1, F2, C2. When the object is behind center of curvature, here they might give you as behind C1 or to F1, both are nothing but the same. You can name it as 2F1 or 2F2. So both are the same. C1 or 2F1, C2 or 2F2. Light ray passing through the, it is when the light ray parallel to principal axis. So after refraction passes through principal focus. So the next ray what you can take is light ray passing through optic center. So what happens? It goes in the same straight line. So both are meeting at this point. So here you will get an image. So it is starting from head. So here it should be there. So here in a lens you can simply take only two ray diagrams, that is light ray parallel to principal axis, after refraction passes through principal focus. Another ray is the light ray passing through the optic center. So they meet here. So that is in between principal focus and center of curvature. So the image is getting formed between principal focus and center of curvature. What is the nature? It is real and inverted. So what is the size? It is diminished. If it is 10 centimeter, the height of the object is 10 centimeter, the height of the image will be less than 10 centimeter. Next, when the object is at center of curvature, so lens, optic center, F1, C1, F2, C2. Object is at center of curvature. Light ray parallel to principal axis. Light ray is parallel to principal axis. So after refraction passes through principal focus. Next, same, light ray passing through optic center goes in the same straight line. So they are meeting here. So the object is getting formed at center of curvature. So what is the nature of the image? It is real and inverted. Size of the image same size as that of the object. If the object is 10 centimeter, the image height will also be 10 centimeter. So it is same size as that of the object. So what is the position? It is at center of curvature. Next, when the object is in between principal focus and center of curvature, optic center F1, C1, F2, C2. When object is in between, so same, first ray parallel to principal axis. So what happens? Passes through principal focus. Next, passing through principal focus. So it goes in the same straight line. So where is the image getting formed? It is getting formed behind the center of curvature. So if the object is 10 centimeter, the image height will be greater than 10 centimeter. So for object in between principal focus and center of curvature, the image is getting formed behind the center of curvature. So what is the nature of image? It is real and inverted. What is the height of the object? It is enlarged. Not highly enlarged, it is just enlarged. So whatever you wrote for the concave mirror, So similar thing for a convex lens. So if you remember one thing, if you remember either concave mirror or a convex lens, you can write for the other. So optic center, principal focus, center of curvature. Optic center, principal focus and center of curvature. Next, when the image is at principal focus, first ray parallel to principal axis passes through principal focus. Next, passing through optic center, it goes in the same straight line. So when you extend this, they will be parallel. So it means that the image is getting formed somewhere at the infinity. But in ideal cases only this happens. But in practical situations, the image will get formed somewhere at some distance. Maybe at, depending on the lens, it gets formed. But it's only in the ideal situation that we say that image is getting formed at infinity, because both the light rays are parallel to one another. If they are parallel, it means that they can't meet. But practically, in the real life, they meet at some point because of there will be minute defects in the lens. Defects in the sense there can be some break or something inside the lens which is making the light rays to meet at some point. So the image is getting formed at infinity. What is the size of the image? It is highly enlarged. Nature, real and inverted. It is not virtual. It is real and inverted. So next, the last image formation in a convex lens. So be careful. Optic center F1, C1, F2, C2. The image is between principal focus and optic center. Same. Parallel to principal axis. After refraction, passes through principal focus. So next, goes in the same straight line which is passing through optic center. If you look at these two ray diagrams, the rays which are getting refracted from a convex lens, so when I extend this behind, it means that they are coming from a common point. So these two, the light ray parallel to principal axis after refraction passes through principal focus. This is passing through optic center and goes in the same straight line. So when I look at this, it keeps expanding. It means that it is getting diverged. So if it is getting diverged, it means that there should be some common point behind. So when I extend this two light rays, it is meeting at one point. So what you do is take a scale, just draw the dotted lines. So the image is getting formed behind the object or on the same side of the lens. So what is this? Is it real or virtual? This is a virtual image because these are the imaginary rays that we are taking. So what is the nature of the image? It is virtual and erect. So position of the image, it is behind the lens or on the same side or behind the object. So what is the size? It is enlarged. So similar thing you saw in a concave mirror. For the position between, there it was pole, but here it is optic center. Between pole and principal focus in the concave mirror, the image was virtual and erect. It was behind the mirror. So similar thing for a convex lens, but for any object between optic center and principal focus, the nature of the image is virtual and erect, and it is on the same side. So this is for a convex lens. So if we take a concave lens, there are only two image formations in a concave lens. similar to what we saw in a convex mirror. In convex mirror there were only two image formations. Similarly in a concave lens we have two image formations. First, when the object is at infinity. When the object is at infinity, so what we take? We take light rays parallel to principal axis. Light rays parallel to principal axis. The optic center F1, C1. Principal focus, center of curvature. So what happens after refraction? The light rays diverge. The light rays are getting diverged. So when I extend this diverged light rays, they meet at principal focus F1. So the image is getting formed at principal focus. So when this light rays diverge and I extend this diverged light rays behind, they meet at principal focus. So the image is getting formed at principal focus. So it is the size of the image is highly diminished or point sized. So what is the nature? It is virtual and direct, because these are not the real light rays, these are imaginary. So the nature is virtual and direct. Size is point sized or highly diminished. What is the position? It is at principal focus. Next, for any distance, you can take any finite distance. Optic center F1, C1, F2, C2. Let me take somewhere here, or let me take behind center of curvature, or it can be any finite distance. So first ray parallel to principal axis. So after refraction, the light ray diverges. So when I extend this diverged light ray, it passes through the principal focus. So the next, what you take is the light ray passing through the optic center. It goes in the same straight line. So where is these two light rays are meeting? So they are meeting here. So this is the point where the image is getting formed. So what is the nature? It is virtual and direct. So this is the point where the two rays are meeting. So the nature is virtual and direct. So what is the position? It is between optic center and principal focus. So what is the size of the image? It is diminished. So similar thing what we saw in a convex mirror. So it's the same for concave lens. The only thing is, in mirror it is reflection and in lens it is refraction. So with this I'll conclude the image formations in concave lens as well as in a convex lens. So we'll see the sign conventions which is similar or same as that we saw in a mirror, except for one particular thing, and we'll solve some of the problems. Thank you. Have a good day.